Good afternoon, everyone. So, welcome to your lecture number 4, and we will be continuing with the chapter of real numbers, right? And in this class, we specifically discuss HCF and LCM using prime factorization, right? These things we've already learned in junior classes, so I'll start with a very simple question. Now, suppose I have two numbers. First number is A, which is written as P raised power 3 into Q raised power 5. The second number is P raised power 4 into Q raised power 2 into R raised power 2. Obviously, these two are natural numbers, right? And P, Q, R, basically they are distinct primes. Now, the two numbers are given to you. I am interested in finding out the LCM of A and B. Right? Now, basically, I have written the prime factorization of A, prime factorization of B. Using the prime factorization, I will try to find out the LCM. Now, first of all, let me just recapitulate what LCM is. LCM, the full form, stands for lowest common multiple. I'm sure you already know this, and you'll be like, why are you just saying the full form, right? Now, look at the word. It says lowest common multiple. Now, if there are two numbers, there would be common multiples, right? There would be infinite number of common multiples, right? I just need to talk about the lowest of them, right? Out of all the common multiples, I need to talk about the lowest or the least one, right? And that is called the LCM. Now, let's think about it. Now, some people know how to do it. They have memorized a slide trick, but we'll understand the logic also behind it, right? Since I'm interested in lowest common multiple, first of all, I'll talk about the common multiple. Now, any multiple of A would have P raised power 3, and any multiple of B would have P raised power 4. I want the common multiple, which is present here as well, here as well. So that means in common multiple, I should have P raised power 4. Right? Now, any multiple of A would have Q raised power 5. Any multiple of B would have Q raised power 2. The common multiple should have this as well as this, right? So I will make sure it has Q raised power 5. Right? Similarly, now I know R is not here, but R square is here. I want the common multiple, which is present over here, which is present over here. That means R square has to be present. And this is the lowest of all the common multiples. That is why this is the LCM. Right? Now, let's do another small question. He says, two numbers are given to you. First number is 2Q into 3 square into 5. The second number is 2 square into 3 raised power A into 5 raised power B. And he says the LCM of the two numbers is given to be 2Q into 3Q into 5 square. You need to find the value of 3A plus 2B. 3A plus 2B. Right? Okay. Now, I want to find the value of this expression. Now, I know if I can find the value of A, I can find the value of B, I can find this value. Now, A and B are getting involved over here. A and B. Right? Okay, let's see. Two numbers are given, LCM is given. Let's see. This has 2 raised power 3, this has 2 raised power 2. In LCM, I will have 2 raised power 3, which is absolutely correct. Fine. Now, this has 3 raised power 2, this is 3 raised power 8. But in LCM, I have 3 raised power 3. That means this number has to be 3 raised power 3. In order for the LCM to have 3 raised power 3. Now, if this is 3 raised power 3, that means A is 3. Right? Now, I have 5 raised power 1 over here. I have 5 raised power B over here. But in LCM, I have 5 raised power 2. That means 5 raised power 2 has to be somewhere. Right? It's not here. That means it has to be here. That means this number is nothing but 5 raised power 2. That means B is equal to 2. Just substitute it and you will get the answer as 13. Right? Okay. Right on the next one. Find, write down, the LCM of 117 raised power P and 78 raised power B. In fact, it says if LCM of this number is K raised power P, then you need to find the value of K. My bad. This is the actual question. Right. I think sufficient time, or you can pause the video and then do the question and then move on with the solution, but I will discuss it now. Now he says LCM of these two numbers is given to be this. So basically I am interested in the LCM of these two numbers. Before I find the LCM, I need to prime factorize it. Now before talking about the prime factorization of this, I'll talk about the prime factorization of 117, which is what? 3 square into 13, right? Okay, so 3 square into 13. Now raised power p is there, raised power p, raised power p. Right? Now this can be written as 3 raised power 2p into 13 raised power p. I'm sure you know the laws of exponents by now. And the second number is 78 raised power p. Right? In fact, I can write the prime factorization of 78, which is 2 into 3 into 13 raised power p, which will give you 2 raised power p into 3 raised power p into 13 raised power p. Now you have prime factorized the two numbers. I will write the LCM. LCM is, now here I have 3 raised power 2p, here I have 3 raised power p. In the LCM, I would have 3 raised power 2p into 13 raised power p, 13 raised power p. In LCM, lowest common multiple, I will have 13 raised power p. Done? Okay. Here the factor of 2 raised power p is there. That should be present in the LCM. So into 2 raised power p. This is the LCM. Now he says LCM is equal to k raised power p. Some number raised power p. Right? The whole part is p, right? So I can write this using the laws of exponents. 3 square into 13 into 2 whole raised power p. I hope you understand how we went from this to this, right? And this is nothing but, it will come out to be 234 raised power p. Now this is equal to k raised power p, that means k is equal to 234. Right? Okay. On to the next one. Write down. If a is equal to 2q into 3 into 7, b is equal to 2 into 3 square into 5, c is equal to 3 raised by n into 5, and LCM of the three numbers, LCM of a, b, c is given to be 2q into 3 square into 5 into 7. You need to find the possible values of n. Possible values of n. Hurry up. Right. I think sufficient time. Let's discuss it. Now we have three numbers and I have prime factorized each of these numbers. Right. Now LCM of the three numbers. Now here it is 2 raised power 3. Here I have 2 raised power 1. Obviously in LCM I will have 2 raised power 3. Absolutely fine. Right. Here I have 3 raised power 1. Here I have 3 raised power 2. And here I have 3 raised power n. And in the LCM I have 3 raised power 2. That means the maximum power of 3 has to be 2. Right? Okay. So maybe I can here have 3 raised power 2. If that is the case, 3 raised power 1, 3 raised power 2, 3 raised power 2. Again, LCM will have 3 raised power 2. So absolutely fine. This number can be 3 raised power 2. So that means n can be 2. But instead of 2, can I put in 1? 3 raised power 1, 3 raised power 2, 3 raised power 1. In LCM, I will have 3 raised power 2. That is fine. So this number can be 1 as well. Also, if I don't have a factor of 3, that means I put in 3 raised power 0. 3 raised power 1, 3 raised power 2, 3 raised power 0. In LCM, it would be 3 raised power 2 itself. So that means n can be 0. So these are the three possible values of n. Alright, now next is a very interesting question. Mind it, I know you know the answer, but you should be able to justify it pretty well. Alright, so write down. Can two numbers have 15 as their HCF and 175 as their LCM? Justify. Even if you know the answer, you should be able to follow the logical reasoning involved in this question. Just use prime factorization and your answer should be there. Hurry up. Alright, now I will be discussing the question on the board now. Right. Can two numbers have 15 as their HCF and 175 as their LCM? Now, it is a part-wise question. He says, can two numbers have 15 as their HCF? So So let me consider two numbers which have 15 as their HCF. That means highest common factor is 15. Now, if 15 is the highest common factor, that means 15 would be here, 15 would be here in the prime factorization. In fact, prime factors of 15 would be here, it would be here. So that means guaranteed the first number would have 3 into 5 and the second number would have 3 into 5. Right? Now there may be some other prime factors or product of prime factors, so let me just denote it by Q. Right? There might be some other prime factors or products, so I will denote it by R. Mind it, Q and R do not have any other commonality. Why? Because HCF is 15. Highest common factor is this only. Now no common factors will be there. So Q and R do not have any common prime factor. Right? Now this was given to us. And somehow LCM, I need to check whether these two numbers can have the LCM as 175. Right? 175 के prime factorization लिख लेते हैं. It is 25 into 7. Okay, I square into 7. 150. Yeah, 25 into 7. Or I should say 25 into 7. Yeah, 25 into 7. Right? I'm getting confused. Cool. So this is 5 square into 7. Right? Now, let's look at it carefully. This is my first number, this is my second number. Right? So, first number has 3 in its prime factorization. Second number has 3 in its prime factorization. Now, let me talk about LCM as the lowest common multiple. Lowest common multiple. Now, any multiple of this number would be distinct into something. Multiple का मतलब ये होता है. If I am talking about the multiples of 7, what I am doing is 7 into 1, 7 into 2, 7 into 3. So the numbers multiply by some natural number. That will give you the multiple. Right? Okay. That means in any multiple, let me actually name this number to be A. That means any multiple of A would have 3 in it. 3 would be present in A, in multiple of A. Right? Let me call the second number as B. Now, mind it, I need to talk about the multiple of B, right? So that means this number into something, into some natural number. Right? Now, can you see the 3 must be present in the multiple of B? Right? 3 is in multiple of B. Now, I need to talk about lowest common multiple. Common multiple. First of all, let's talk about that. Now, 3 is in multiple of A. 3 is in multiple of B. So, do you think 3 will be present in the common multiple of A and B? Of course. 3 is in common multiple of A and B. Wait a second. 3 is present in the common multiple, right? Any common multiple you take it. Now, will 3 be present in the lowest of them? The answer is yes. 3 is in the lowest common multiple, which is LCM. Right? Now, 3 is in the lowest common multiple. Now, let's look at this number. Does it have 3 in its prime factorization? The answer is no. If it does not have 3 in its prime factorization, do you think this can be the LCM of these two numbers, which should have 3 in its LCM? The answer is no. This cannot be the LCM because it lacks the factor of 3. So the answer to the question, can two numbers have 15 as their HCF and 175 as their LCM? The answer is no. And this is the justification. Now, obviously after this, some people might wonder, is it true for every case? Is it true for every natural number? Let's think about that. In fact, the justification moves on the very similar line, or we should say on the same line. Think about it. Now think about this when we are talking about any two natural numbers. Right? Let's discuss it. Suppose I have the two natural numbers as A and B. There would be some HCF, right? I do not know what that HCF is, but there would be some. Right? In HCF, obviously, I will prime factorize it, so there would be some prime number. Right? I do not know, and let me just denote that prime number by P. I am taking just one prime number, right? There might be other prime numbers in the HCF, but I am just taking one. Now this P is present in the highest common factor. Do you think P would be present in the factorization of A? Of course, common factor is there, right? So P would be there. Do you think P would be present in the prime factorization of B? Yes. Right? Now there might be some other prime factors, we do not care. There might be some other prime factors, we do not care. Right? Now let's talk about LCM as in lowest common multiple. In lowest common multiple, first I'll talk about the multiple of this, then multiple of this, and the common multiple. Any multiple of A would have P in it, because multiple of A is nothing but this number into something. Right? It would definitely have this number P. P would also be present in the multiple of B. So P is present in multiple of A. P is present in multiple of B. So दोनों भी multiples में आ रहा है, वो common multiple में भी आएगा, right? So P would be present in the common multiple of A and B. Right? Now, if it is coming in all the common multiples, it will come in the lowest common multiple. So P has to be present in the LCM. So that means if there is a prime factor P in HCF, that prime factor should be there in LCM. Right? Now, you say, ma'am, there might be some other prime factors, it's fine. Suppose Q is there. Now, on the same lines, you can argue if Q is present in the HCF, Q has to be present in LCM. Right? In fact, any prime factor you take, which is there in HCF, that prime factor has to be there in LCM. And if all the prime factors which are present over here are present in LCM, so let me just imagine it. So suppose LCM is here, HCF is here. If all the prime factors of this number is present in the LCM, all the factors will get cancelled, right? And it would be completely divisible. Or we can say that HCF divides LCM. And in fact, I should make it a better statement. I would say HCF always divides LCM. Right? This is a general kind of justification. Alright, so now we can use this result, or in fact we should not even call it result because this is basic common sense. So we'll use common sense to do further questions. Write down. If LCM of two numbers is 36, what are the possible values? What are the possible values of HCF? Hurry up. I think sufficient time. Now he says LCM of two numbers is 36. What are the possible values of HCF? Right now we just said that HCF divides LCM. Right? Now LCM in this case is 36, so HCF should divide 36. So that means I need to think of such numbers which divide 36. So just write down the factors of 36. You can do that orally. 1, 2, 3 is there, 4 is there, then 6 is there, obviously, then 9 is there, then 12 is there, then 18 is there, then 36. Right? All of these numbers can be the HCF. Now, it would be a very fun thing to do. Imagine that HCF is 1 and LCM is 36. You can think of the pair of numbers which have this thing. So, you can take HCF to be 12 and LCM to be 36, and you can think of the two numbers which obey this property. Right? But this is the answer. These are all the possible values of HCF. Right? On to the next one. Write down. Find the product of HCF of 360 and 756 and LCM of 360 and 756. Find the product of HCF and LCM. Hurry up. In order to find the HCF and in order to find the LCM, you need the prime factorization of the two numbers. Right? So I will just write the prime factorization first. So 360 can be written as 2 cube into 3 square into 5. And 756 can be written as 2 square into 3 cube into 7. Right? Now, you know the two prime factorization. Let me write the HCF. HCF, highest common factor. Careful. Common factor, that means 2 raised power 3, 2 raised power 2. In common factor, it would be 2 square, or 2 raised power 2. 3 raised power 2, 3 raised power 3. In common factor, it would be 3 raised power 2. Now, 5 is present over here, 5 is not present over here. So, in common factor, it would not be there. Same thing with 7. So, this is my HCF. Now, let me write the LCM. This is lowest common multiple, careful. So, 2 raised power 3, 2 raised power 2. I will have 2 raised power 3. Then 3 raised power 2, 3 raised power 3. I will have 3 raised power 3. Now, in multiple, I have 7. So, that means in common multiple, I should 5. In multiple, I have 5. So, in common multiple, I will have 5. Same with 7. This is my HCF and this is my LCM. Now, I want the product of this, so I'll just multiply it. I know the laws of exponents. So, HCF into LCM, I will write it down. 2 raised power 2 into 2 raised power 3. Now, the powers will be added, so careful. So, this is 2 raised power 5 into powers will be added 3 raised power 5 into 5 into 7. Right? This is my HCF into LCM. Now, if you look carefully, this is 2 raised power 5. If I multiply the two numbers, will I have 2 raised power 5? Yes. This is 3 raised power 5. If I multiply the two numbers, I'll have 3 raised power 5. Okay. Then 5 is there. If I multiply, 5 is there. 7 is there. If I multiply, 7 is there. In fact, this number is nothing but the product of 360 and 756. HCF into LCM is nothing but the product of the two numbers. This is a very special property. And this is not true only in this case. It is true for any two natural numbers. Right? You can say that HCF into LCM is equal to first number into second number. Or you can say the product of numbers. This result holds for any two natural numbers. Alright? Okay. Now, basis of this, what kind of questions can come in school exams? What they can do is, since there are 4 quantities involved, they might give you first number, they might give you the LCM, they might give you the HCF. Using these three, find the second number. Can you do that? Yes. 3 quantities are given, you can find the fourth one. Then they might give you HCF, they might give you the two numbers, then you need to find the LCM. Again, you can do that. Right? In this various ways, you can use this property. Now, write down one question. Given HCF and LCM of two numbers as 45 and 9450, if one of the numbers is 450, find the other number. I think the answer is there. You can clearly see it. We'll use this thing only. I think sufficient time, right? Now, HCF and LCM is given, so product of HCF and LCM, so 45 into 9450, HCF into LCM is equal to first number into second number. First number is 450. Second number, I am interested in finding out the question mark, right? Just shift the 450 to that side and you'll get the value of question mark, which is 945. The second number is 945. Moving on. Now, the next set of questions is quite interesting and that will demand a little bit of common sense, so you should be ready for it. Write down the first one. If HCF of two numbers is 21 and the sum of the numbers is 105, find all possible pairs of such numbers. Right, you can definitely pause the video and then move forward, but I'll discuss it now. Go on the board. Now he says HCF of two numbers is 21, okay, and the sum of the number is 105. Find all such possible pairs of numbers. So I'm talking about two natural numbers, first number and second number. Now he says the HCF is 21. Now highest common factor is 21. That means 21 should be present over here and 21 should be present over here. So that means in prime factorization I should have 3 into 7 and in the prime factorization I should have 3 into 7. Now along with this I can have more numbers. So either prime or product of prime, so basically composite. Then I can have more prime factors. Mind it, since HCF is 21, that means Q and R do not have any common factors. In fact, Q and R do not have any common prime factors. Q and R, no common prime factor. Very important, because if there is a common prime factor, the HCF would change. Right? So basically this number becomes 21Q. This number becomes 21R. Now the next thing that is given to us, that is sum of the numbers is 105. So that means this plus this. So 21Q plus 21R is equal to 105. Right? Obviously I can take 21 common, then I can take 21 to the other side. I will get Q plus R to be 5. Right? Now Q plus R is equal to 5. This is an equation. You will say, ma'am, linear equation in two variables. We do not know how to solve it. Mind it, Q and R are definitely what? They are natural numbers. Now, if Q plus R is equal to 5 and these two are natural numbers, you can guess the solutions. First thing, Q can be 1, R can be 4. Second, Q can be 2, R can be 3. Then Q can be 3, R can be 2. Q can be 4, R can be 1. These are the only set of solutions which satisfy this equation. Natural numbers. Right? So let me think my numbers then. My numbers were 21Q and 21R. 21Q and 21R. So first Q is 1, so 21 into 1 and 21 into 4, which is 21 and 84. One set of numbers which have the HCF as 21 and the sum is 105. Second set of numbers. Now Q is 2, R is 3, so 21 into 2 and 21 into 3. That means 42 and 50. Another set of numbers which has the HCF 15, which has the HCF 21 and the sum is 105. Right? Okay. Next one. Q is 3, R is 2. So 21 into 3 and 21 into 2. This is 63 and 42. Now pairs of numbers, either pairs of numbers, you are saying 42 and 73 or you are saying 63 and 42. You are talking about the same pair? So why I am repeating this one? Next one also, 21 into 4 that will give you 84, 21 into 1 that will give you 21. That you have already written, so I will not talk about this pair again. So there are just two pairs of numbers, 21 and 84, and the second pair is 42 and 63 which satisfy these two conditions. Right? Okay. Write down the next one. If HCF of two numbers is 28 and their sum is 168, find all possible pairs of such numbers. I think sufficient time. Now, he says HCF of two numbers is 28. So let me imagine my two numbers. First, second. HCF is 28. That means HCF should be present over here. HCF should be present over here. That means prime factors like that. So 2 square into 7 is present. 2 square into 7 is present. Now, there might be some other prime numbers. Or it can be product of prime. Say कोई भी numbers हो सकते हैं, prime composite anything. Right? Mind it, Q and R do not have any common prime factor. Because, take note of the HCF. Q and R, no common prime factor. Right? So this number basically becomes 28Q. This becomes 28R. Now it says the sum of two numbers is 168. This plus this, so 28Q plus 28R is equal to 168. You can take 28 common and you'll get Q plus R is equal to 6. Right? Now, this is an equation and I know that Q and R are natural numbers. That means I can write the answer. Q plus R is equal to 6. Let me look at the solution. 1, 5, 2, 4, 3, 3. Now the other solutions 4, 2 and 5, 1. They anyway rejected by repetition. So rejected. Also, mind it, you said that Q and R do not have any common prime factor. No common prime factor is there, right? Look, if Q is 2, R is 4, do you think it has a common prime factor? Yes, 2. But he says no common prime factor. That means, can you take Q as 2 and R as 4? The answer is no. Because there is a common prime factor which is 2. Right? Next, can you take Q as 3 and R as 3? They have a common prime factor which is 3. So definitely I cannot take. So in this case, just one thing is possible. So Q is 1, R is 5. So my numbers are 28 into 1 and 28 into 5. Which is the answer? So 28 and this is 140. One pair of numbers. Right, on the next one. If HCF of two numbers is 15 and the sum of the two numbers is 480, find all possible pairs of numbers. I think we know what to do. In fact, find all categories. Find the number. Just the number. Find the number of possible pairs of such numbers. Just the number. How many these are? Right, I think sufficient time. Now, HCF is given to be 15. So, the two numbers would have 3 into 5. 3 into 5. There would be some other number, Q. There would be some other number, R. Mind it, Q and R, no common prime factor. Cool? Right. Next, my numbers become 15Q and 15R. He says sum of two numbers is 480. So, 15Q plus 15R is equal to 480. Alright, so Q plus R turns out to be 32. Right, 32. 30. Yes. Now, mind it, these two are natural numbers, so I can write the solutions very quickly. Q plus R is equal to 32. So, let's see. 1, 31, then 2, 30, 3, 29, 4, 28, 5, 27, 6, 26, 7, 25, 8, 24, 9, 23, 10, 22. Now I will write it here. So Q plus R is equal to 32. I will start with 11, 21, then 12, 20, 13, 19, 14, 18, 15, 17, 16, 16. Now, if you write 17, 15, you have already considered that. If you write 18, 14, you have already considered that. Those will give you the same set of numbers. That's why I am not writing ahead. Now, mind it, Q and R have no common prime factor. So 1 and 31, no common prime factor, so I like them. I will take them. 2 and 30, they do have a common prime factor. I do not want them. 3 and 29, no common prime factor. I want them. 4 and 28, they have a common prime factor. I do not want them. I want this. Again, this one. This is cut. I want this. I don't want this. 11, 21, no common. So yes, I want this. Not this. I want this. Not this. I want this. Not this. Right? Because these ones have a common prime factor. So how many pairs are? 1, 2, 3, 4, 5, 6, 7, 8. So 8 pairs of number would be there whose HCF is 15 and the sum of number is 480. And if you want to write the pairs, you can write 15 into 1 and 15 into 31, then 15 into 3, 15 into 21, 29 and so on. But he is just asking the number of possible pairs. Right? Let's write down the next one. If HCF of two numbers is 13 and the product of the numbers, now it's product, and the product of the two numbers is 6760, then you need to find the number of possible pairs of such numbers. Right. I think sufficient time. Again, HCF of two numbers is 13, so I can consider my numbers to be 13Q and 13R. Right? Where Q and R, no common prime factor. Because I have said the point again and again, so I am not repeating it. Now he says the product of two numbers. So that means this into this. So 13Q into 13R, that is equal to 6768. Right? So Q into R actually turns out to be 40. Right? Mind it, these two are natural numbers. This is a natural number, this is a natural number. So 40 has been expressed as product of natural numbers. I can do that very well, right? So Q into R is equal to 40. So I can write 1 into 40, then I can write 2 into 20, then 4 into 10, then 5 into 8. Again, if I write 8 into 5, again repetition is there, that's why I'm not writing it. Right? But you need to check whether repetition occurs or not. Right? Now I have to make sure that Q and R have no common prime factor. So obviously I want this. I do not want this. I do not want this. I want this. Right? So just two pairs of numbers are there for which the HCF is 13 and the product of numbers is this one. Right? If you want to write the pair, that is 13 into 1, 13 into 40. The second pair is 13 into 5 and 13 into 8. Right? Now, the next one. And it's a very interesting question. You just need to read the question well. Right? So, write down the sum of two non-co-prime numbers is added to their HCF and the result is 91. Find all such pairs of numbers. Find all such pairs of numbers. Alright, you can definitely pause the video and attempt it, but I'll be discussing it, so on the board now. Now, here says sum of two non-co-prime numbers. Right, so I need to talk about two numbers. And he says these two numbers should be non-co-prime. That means which are not co-prime. First of all, think of numbers which are co-prime. Co-prime numbers are those numbers whose HCF is 1. He says not co-prime. So that means the HCF should not be 1. That is what I understood. HCF cannot be 1. Then you need to talk about two numbers. The thing is, in the previous question, HCF was given to us, right? And we used to think since HCF is given, that means those prime factors will be present. Now, HCF is not given to you. It's absolutely fine. You can imagine the HCF to be something. Take it to be X. It would be something, right? So, I am taking my HCF to be X. Right? And I know X cannot be equal to 1. So, guess what? Now, HCF is X. That means in the two numbers, definitely X will be present. Right? In the second number, X will be present. Now, along with this, it would have some number that is Q, some number which is 1. Again, Q and R do not have any what? Q and R, no common prime factor. Because I have taken my HCF to be X. So that means यहाँ से कोई common factor नहीं आएगा. Otherwise, I will change my HCF. Right? So basically, my two numbers are XQ and XR. Right? Now he says the sum of the two numbers. Right? So I can have the sum. So that is XQ plus XR. So this sum is added to their HCF. So this sum is added to their HCF. HCF is what? X. This sum is added to plus sign. Right? So this sum, he says the result is 91. Right? Now I think the situation is pretty clear. X, let me take X common. So X into Q plus R plus 1 is equal to 91. Now mind it, 91 product of two numbers. In fact, product of two natural numbers. Why? X is definitely a natural number. This quantity C is definitely a natural number. Right? So let me write 91 as product of two natural numbers. So you can say 1 into 91. Mind it, can X be equal to 1? Can X be equal to 1? No, he specifically said no. So that means this cannot be the case. How else I can write 7 into 13? That can be the case. Then I can have 13 into 7. Mind that here you are saying that x is 7 and this quantity is 13. And in this case you are saying x is 13 and this quantity is 7. These two quantities are different. That means these are two different cases. Right? Now you will not say, ma'am, wo aapne interchange kar diya, so I will not. No. You need to analyze it, what is happening. In the previous question, that is very different thing. Here it is quite different. Right? Then you can say 91 into 1. That is also the case. But mind is q plus r plus 1. Now q is a natural number, r is a natural number. This term cannot be equal to 1. Right? That is why just two cases. Cool? Now, let me consider the first case. First case is x equal to 7 and q plus r plus 1 is equal to 13. Q plus r plus 1 equal to 13. So q plus r turns out to be 12. Right? Again, q and r are natural numbers. So let me see. So 1, 11, 2, 10, 3, 9, 4, 8, 5, 7, 6, 6. Now if you write 7 and 5, that will be a repetition. Check it out and you will understand it why. Right? So I will not write it further. Now q and r, where is it? Yeah, no common prime factor. Right? So I will take this, I will reject this, I will reject this, rejected, I will take this, rejected. So in this case, I am just getting two numbers. So let me write the numbers. Now, x was 7, my two numbers are where? Xq and xr. So x into q. So x is 7, q. So 7 into 1, and the other number is 7 into 11. Because xr. Right? Then next is 7 into 5 and 7 into 7. Cool. So this number is obviously, if you want to write it, 7 and 77. And this is 35 and 49. Right? Now, my second case, second case is x is 13 and q plus r plus 1 is equal to 7. That means q plus r is equal to 6. Let me write the solutions quickly. 1, 5, 2, 4, 3, 3. Obviously, these two are rejected. Right? From here, I need to write it. So, again, xq and xr. So, xq of x into q, which is 13 into 1, and then x into r, 13 into 5. So, this is 13 and 65. So, basically, three pairs of number 1, 2, 3. Three pairs of number would be there which satisfy this condition. Alright, let's move on to the next one. Write down. If HCF and LCM of two numbers is 2 square into 3 into 5 and 2 cube into 3 square into 5 respectively, then find all possible pairs of numbers. Pairs of numbers. Hurry up. Now, HCF and LCM is given of two numbers, right? So, let me take my numbers. Now, HCF is this. That means these prime factors would be present in the prime factorization. So, my numbers should have 2 square into 3 into 5. Then 2 square into 3 into 5. Along with this, there would be some other number. In fact, I am interested in finding out in how many different ways can I fill these two. Now, mind that LCM is given to be this. 2 cube into 3 square into 5. Now 2 cube is there. That means in one of the numbers I have to make 2 cube. Right? 2 square is already there. That means I have to put in another 2. Right? So 2 is the extra factor that I need to put in one of these. Right? Okay. Then 3 square is there. 3 I have already put in. That means in one of the numbers I need to put in 3 as well. 5. Now 5 is there. 5 is there. I do not need to put any 5. So So these two factors I have to arrange or have to put in these two numbers. Now two factors are there. Now one way is I can put both of the factors in one of the number and वहाँ पे कुछ नहीं जाएगा तो मैं 1 लिख देता हूँ. Right? This is one way of doing so. If that is the case, the two numbers will turn out to be, this turns out to be 360 and this turns out to be 60. Yeah, 4 into, yeah, cool. Right? Now, what other possible ways can be? So my number was 2 square into 3 into 5 into something and then 2 square into 3 into 5 into something. And I realized I need to put in 2 and 3. Now, one way I'll put both of them in one. Now what I'll do is I'll put one of them. So let me put 3 over here, let me put 2 over here. In this case, you will get the numbers as 180 and 120. Right? Now you might say, ma'am, you could have put 2 over there and 3 over there. If you're just interchanging, you will realize you just written 120 and 180. Just interchange the numbers. And I'm just talking about the pairs. Right? Then that case I've already written. Then one thing you can say, ma'am, in the second number you could have put 2 into 3 and the first number you could have put just 1. Again, the pair of numbers remains the same. You write 360 and 60 or you write 60 and 360, that's one of the same thing. Pair of numbers remain the same. Right? Just 2 and 3 ko dana tha. These are the only two possibilities in which you can achieve this. Right? So this is one pair. And this is another pair, which have the HCF as this and LCM as this. Right? Now, on to the last question of the class. If HCF and LCM of two numbers is 126 and their LCM is 34,020, find the number of possible pairs. Now you don't need to write the pairs, you just need to write how many numbers, how many they are there. Obviously, since HCF LCM is there, you need to prime factorize it. Right? So first thing that I'll do is I'll write HCF as in terms of the prime factors, which turns out to be 2 into 3 square into 7, and LCM turns out to be 2 square into 5 into 3 raised to 5 into 10. Right? Now HCF is this. That means in the two numbers, definitely this will be present. 2 into 3 square into 7 and 2 into 3 square into 7. Along with this, something. Along with this, something. Now mind it, LCM has 2 squares. Right? So that means in either of these two numbers, I need to put in 2. Extra factors there. So I will write it here. Extra which I need to accommodate 2. Then 5. LCM has 5. That means in one of these numbers, I need to put in 5 as well. So 5 is the extra factor. Then LCM has 3 raised to 5. I already have 3 squares. That means I need to just 3 cubes. Or you can say 3 into 3 into 3. Then 7 is there. Now 7 is already present. That means 7 I do not need to put in anywhere. Right? So I have these 3 factors and I need to have it over here. Right? I need to arrange it here basically. One way is I can put all of the 3 in this one and just 1 in this one. All of the 3. That means 2 into 5 into 3 के भी आ रहा है. यहाँ पे कुछ नहीं आ रहा है, that means 1 आ रहा है. Cool. Now you can say instead of putting all the 3, you can put just 2. Right? So I will put 5 and 3 cube here and 2 I will put it here. Now the thing is 2 you would put it here, maybe you could have put in 5 here, so that means this is 2 into 3 cube. That is also the way. Right? Then you could have put 3 cube over here, then you could have gotten 2 into 5. Now question is, you will be like, why are you always keeping 3 cube together? What if you put, if you want to imagine, 3 here and 3 square here? Mind it, if you separate out the 3, that will be a problematic thing. Why? Because these two numbers, they do not have any common prime factor. Told this so many times, right? Because this is the HCF, that means these two numbers should not have any common prime factor. That means you cannot divide 3 like this. 3 you put for the 3 square. No, that you cannot do. So any prime factor that is there, that will go in its entirety. You cannot separate them out. Right? So let's see the cases. All three, then 2, 2, 2, सारी combination ले लिया मैंने. Anything else? Then 1, put करोगे तो 1, that you've already considered, so I will not write it again. So these are the only 4 possibilities. 1, 2, 3, 4. If you want to write the possibilities, first is this into this, and second is this into 1. Second possibility is this into this, and second this into this. Third, this into this, second this into 5. And last, this into this into this. Right? So I'm hoping you can see how 4 factors are occurring over there. And this will give us 4 pairs of numbers. Right? Now these kind of questions need a lot of practice, so that is why the assignment in this case is quite important, which has already been uploaded, so I'm hoping you will do it on time. Right? So that's it for today. I will see you next time.